Hello. uh, okay, let's coming to the next part. 61. So ultimately in the previous session I have calculated the value 61. How we calculate? The 6000 by 100 plus 1. Okay, so obviously we have to end up with a single bar, so 60 plus 1, that is 61. So I have to distribute this 61 value into crank as well as straight bar. So I am taking the crank 31 and straight 30. It is not mandatory, you can take both alternately 30 31, but I am taking the crank bar 31 and straight bar 30. Okay, now crank bar. Now I have to calculate the length of the crank bar. Look, simply in section AA, first I will tell you how many types of bars are there. First one is crank bar, second one is straight bar, and third one is top bar. Okay, so here you can see, look, this is the I'm taking the pen. This is the crank bar, this is the straight bar, and these are the top bar. Okay, we will calculate these three types of bar. Okay, first crank bar. So crank bar will be the, first of all we will calculate the length. So L is 5000. How can I calculate 5000? Look over here, this is 5000. So in section AA we calculate the number of bars using this length, and we calculate the length of the bar using this length. Okay, so this is the length of the bar. We will take the similar technique we use in the for the calculation of the beam. So 5000 plus this crank. So how many cranks are there? There are 2 cranks, 1 and 2. So 2 into 0.42d. Here LD is also 2. Okay, now 45 degree bend is 1 2 3 4, and 90 degree bend is 1 and 2. So if you see the previous video of calculation of beam, you can also do this. Crank, this is LD, and this is minus bend. So 5000 minus 0.42d into 2, 50d into 2, 4 into 1d, 2 into 2d. This D value is, I think, same as the previous beam problem. D value, one second, I think we have already calculated. Okay, I am showing the D value here. This is the D. 45 degree, the angle sine 45 degree dy x. So dy 1 by root 2, here it is 1.42 and it is 0.42 d. Okay, no, d is calculated in this problem here. This is the d. Look, so d is 200 minus 2 into 25 minus 12. I think in slab the values are also same. 200 is our slab depth, 25 is the clear cover, and 12 is the dia. Okay, now the center to center distance you can calculate here. This is comes around 138. So we will take the same value. Look here, the depth of the beam is 200 mm. Okay, the cover is 25 mm, same, and the what another thing, and the edge, the bars is also 2 mm. So all the values are same, so capital D value will be same, 138. So you can put over here 138, this is 138, this D is 12 mm, this D is 12 mm, this D is 12 mm. So you will have the value that is 6.22 meter. Okay, so we have the crank bar is 31 numbers of bar. So 31 number of bar, that means 31 into 6.22, that is 1.192.82 meters. Okay, so when you go to the market, or you want to buy a reinforced bar, so you have to toll the number of bars, not the length of the bar. Okay, so you know the length of the single bar, that is around 12 meter as per standard, 12 meter. So you can divide the 192.82 meter by 12 meter, so you will get the value how many numbers of bars are required, and you can buy the reinforced bar. Okay, now second part, that is straight bar. So in straight bar is very simple, you just have to calculate the length. The L is already known, that is 5000. You just see the diagram, and LD is the development length, because there is no another things are over here. there is no bend, so there is no subtraction. Look, in straight bar, the straight bar is only from this point to this point. Okay, so simply I have to calculate the 5000 and the LD, means the extra length both side. So extra length is LD, that is 50D. So 5000 plus here 50D and here 50D. Okay, you see the calculation. Look, 5000 and 2 into 50D, 6.2 meter. So for 30 numbers we already have total 30 numbers of straight bars. So 30 into 6.2, that is 186. Okay, now the final portion, the top bar, the main important part in this topic. Okay, how many times left? Okay, top bars. Okay, you just imagine when this crank bar, this is crank bar, this crank bar and straight bar are placed alternatively in not only single direction as it is two-way slab, in both direction. You just assume in both direction. Okay, now in these four corners there will be a mesh, there will be a mesh formation. You just imagine over here it will be a mesh. If you have a 3D concept, I already shared a beautiful video of BBS of one-way slab and two-way slab. You can see over there also a mesh is formed. So this is the kind of diagram where I show the mesh is placed in these four corners. Okay, and another thing, in the first diagram you can see over here the distance from the inside of the beam to the bent up portion, that means this portion, this is given as L by 5. This is as per code, this is not mandatory, it is always L by 5, it can be L by 4 also, that means it is L by 4 to L by 5. Here it is L by 5, the value of L is 5 meter, and so this distance will be 1 meter or 1000, right? So it will be needed in our calculation to calculate the top bar, and this will be L dash by 5, that means 6000 by 5, that means 1200, right? Okay, come to this diagram. Yeah, so the mesh is formed in the four corners. So I need to calculate the top bar. So where is the top bar? Top bar is these three are the top bar. Now you just imagine, first I have to, one second, I will remove all these things. Just imagine that these three circular aerial section should be placed something like this portion, right? Something like this. So I need to calculate firstly this number, the spacing I already know, the spacing of these bars I already know, that is 100, because all the spacings are 100 center to center. Okay, so I just need to calculate the number of bars firstly. Okay, so to determine in this particular section the numbers of bar, I need to take this distance, right? I need to take this distance, and this distance is nothing but L by 5. Now if I take this distance and divided it by 100, that means L by 5 divided by 100 plus 1, obviously I have to end up with a bar, plus 1, I can get the number of bars over here, that means the number of bars in these positions, right? Now if I multiply it by 2, I can get the number of bars at both sides. Very much simple. Look, whatever it is, same thing is done over here. Look, they just calculate the number of bars at A section, 5000 by 5. Look, this is 5000 by 5. By spacing, the spacing is nothing, 100 plus 1, that means end up with a bar, and into 2, that means in both sides. So I have calculated the number of bars in this both side. Okay, next part in the next video.